This is Pavement Black.
Hi, everyone, and welcome to Pavement Black, the official podcast of the National Asphalt Pavement Association. My name is Richard Willis.
And I'm Brett Williams.
Today, we're here to talk about plastic. About 2 years ago, this topic became very important, not just globally, but for the asphalt industry as well. China decided that it was no longer going to accept plastic waste from other countries, which started diverting a lot of plastic back into the United States and other countries across the globe. Today, it's estimated that about 19% of the municipal solid waste in this country is plastic alone. And what are we going to do to solve that issue? Well, shockingly, some people want to put it in asphalt. But with people looking at legislating this issue, people looking at climate change and how are we going to use recycled materials more responsibility, and boom, it puts the problem straight in our doorstep.
When we look at plastic, what are we trying to solve? Are we trying to solve the plastic industry's problem? Or are we trying to not only solve the plastic industry's problem, but also do something that helps enhance our efforts to create quality infrastructure?
You're absolutely right, Brett. The question is it responsible to recycle? So to help us talk about this issue, we've invited Paul Lum from Colas to come in and speak with us for a little bit today. Hey, Paul, how are you doing?
Good morning, Richard. How are you doing? Good morning, Brett.
Doing great. Before we get into the meat of the conversation, just tell us a little bit about yourself. Tell us about Colas so people can understand the view that you're bringing.
So I'm a civil engineer. I joined Colas in 2019 as their technical director for all of the United States there. And previous to that, I spent 3 years with CRH in their products division, asphalt, concrete, and aggregates. And then prior to that, I was with Lafarge in their asphalt and construction business and spent a lot of time on asphalt materials. And so as technical director for Colas Inc., I'm responsible for product innovation, pavement solutions, and also coordinating with the quality control departments within Colas Inc. in the United States and all of our subsidiaries. And Colas Inc. is a very large company worldwide, but within the United States, it exists as Colaska in Alaska, Sully Miller in California. We've got Reeves, Branscombe, Simon, Delta, and of course Barrett Pavement Materials. So those are the main subsidiaries and a fairly large asphalt paving company. Colas Inc. and Colas SA, they've got a strong culture for product innovation. A lot of it coming from France, for instance, which is where Colas SA is headquartered in Paris. They've utilized the polyethylene into HMA. They've utilized recycled mirrors into asphalt to make reflective asphalt. And they've come up forward with new technology as well to address sustainability within our society moving forward there.
So plastic really isn't something as simple as just one thing. In fact, I think there's numerous different types of plastics out there. Anything from low density polyethylene to high density polyethylene to PET to, all these different plastics. So I'm hoping maybe we could talk a little bit in general about the differences between some of these plastics and maybe give some examples of the different types and what those might mean for using plastic in asphalt.
Yes, there are many different types of plastics from the plastic industries that we need to consider if we want to recycle plastics into HMA. And to start with, there's the low-density polyethylene and linear low-density polyethylene. And these types of products are used to make grocery bags, for instance, or saran wrap. And they generally have a melting point between 220 and 320 degrees Fahrenheit. And melting point is very important with our asphalt technology when we want to recycle. Polystyrene is appliances, electronics, automotive parts. And then we've got high density polyethylene, and these types of plastics are used to make plastic bottles and toys. And this type of plastic has a melting point between 250 and 356 degrees Fahrenheit. Then there's polypropylene, which is used to make food containers such as margin tubs. and it has a melting point between 270 and 340 degrees Fahrenheit. And then we get into the higher end types and stiffer type plastics, such as polyethylene, terephthalate, or PET type plastics. And these are used to make water bottles. And these types of plastics have melt points between 480 and 500 degrees Fahrenheit. And then the toughest type of plastics we have available are the polyvinyl chlorides, or PVC. And these plastics are used to make building construction materials such as window frames, water pipes, wire and cable insulation. And these ones have a melt point anywhere from 212 to 500 degrees Fahrenheit.
People talk about plastic all the time like it's a singular material, but it's complicated. And it's not just the physical properties like you were talking about with things like melting point. It's availability and waste stream. We look at some of the EPA statistics. The 2017 was, I think, the last time they've released plastic numbers, but only like 17% of the plastic waste stream is even low density or linear low density, and 11.7% was high density polyethylene. So we're looking at plastics that would actually melt in an asphalt plant, maybe not even being a major portion of this plastic waste stream that we're working on. So we're hearing about this stuff on social media all the time, even more traditional media like the Washington Post and the Economist, two things that you would think would never run an article about asphalt chemistry, have gone and started talking about this. And one of the things I learned early in my tenure at Napa from our marketing and communications people was that marketing trumps engineering every day of the week. And over time, I have come to be resigned to that conclusion as well, because a message gets out, people hear about companies that are doing this, and they've made it look so simple, but there's still not a lot of data that supports kind of what's going on and what we really should consider to make this a truly, or to even evaluate if this is a truly viable product for the industry. You talked a little bit about melting point, but what are some of the other engineering concerns or questions that we really should be looking forward to trying to find these answers to help us understand, yes, no, maybe more research needs to be done kind of a thing?
These are good points, Richard. Recycling polyethylene into HMA can be looked at two ways. There's a wet process and the dry process. And this is very similar to GTR, ground tire rubber, where ground tire rubber technology today exists both as a wet process and a dry process. And in the wet process, we're physically taking the recycled polyethylene, and this would typically be done at an asphalt cement terminal or a binder terminal. And you're adding the recycled polyethylene in with types of reactive chemicals and bonding chemicals to make sure that you can stabilize the polyethylene within the asphalt cement, both in short-term and long-term storage stability, because that'll be key in that process there. And that's where it's controlled, absolutely. And there are health and safety concerns at the mixing terminal plant for sure. And then we have the dry process where we're actually introducing recycled polyethylene at the hot mix plant in with the hot aggregates there. And so now we're also in an open environment, but it also needs to be controlled. So this would be akin to using the types of blowers we use, for instance, when we're introducing fibers into stone mastic to manufacture stone mastic asphalt. So technology exists today. And in fact, two companies like Novafalt and Polyfault back in the mid-90s actually had commercialized recycled polyethylene into the bitumen component side of it. What I left off my resume was I actually spent a year at Polyfault. From my perspective at that time, and this goes back to 1996, I looked at it purely as, this is a marketing avenue, because today we have more knowledge about low temperature cracking and fatigue cracking than we did in the mid-90s. I believe that's why recycled polyethylene did not succeed as back then, right? Was we didn't have all the tools to be able to answer the performance problems we were seeing. Today, I think with better engineering tools, we'll be able to manage and appropriately engineer recycled polyethylene into hot mix asphalt. And that's key to it, right? Is we as asphalt technologists, we got to make sure that what we offer to the highway engineers is a product that's going to be equivalent or better than conventional mixes without recycled products in it.
It's kind of a similar story to what happened with recycled tire rubber. When people were using it some in the early 90s, the science and the technology hadn't matured enough to the point where people really understood how to do it successfully. The challenge for plastics is little research was done in that phase period between 1995 or 1999 and today, whereas people continued to kind of experiment more with the ground tire rubber. You mentioned the health and safety aspect of that. I think that that's one thing that, we haven't even started scratching the surface of that just from a worker standpoint. What are you aware of, or what questions should we be talking to OSHA or NIOSH about, or other organizations to try to help us understand how do we ensure we're providing a safe environment for our workers if we're starting to use these types of materials?
Exactly, Richard. Health and safety should be first and foremost, along with, the engineering to make sure that we can recycle products. And so any new product we bring forward, like recycled polyethylene, whatever projects are being done, trial projects, we need to make sure that we engage and identify what are the possible impacts we'll have both at the terminal side with our workers, at the bitumen terminal, at the hot mix plants, and then on the job site. So it may entail that we lay out a health and safety plan where we've got our workers wearing badges that are actually measuring for specific dioxins, toxins over that time period of the shift. We're doing a trial near soon, and that'll be part of the activity, is actually quantifying the emissions in there. What I can say is the work that Colas has done in France, there were no issues with emissions, but that was France. So obviously when you do something in US or Canada, we always tend to redo things just to make sure in our own minds we're meeting our regulations within the jurisdictions that we operate within, and that's fair.
Some other areas that might be of question or things that we'd be interested in learning more about is maybe how plastics could impact the environment if they're incorporated into pavements, or if there are things to consider with putting a plastic into an asphalt pavement and what that might be for the environment.
Yeah, certainly, Brett. Recycling polyethylene or plastic into hot mix that gets built into roads is a viable solution. We just need to make sure that from a performance standpoint, it meets our needs. We read stories of plastic bottles and bags polluting the ocean, and it takes many, many years for them to degrade, if they even degrade into atoms. I don't see plastics, if it's done properly in the small dosages that we're talking about here from a research standpoint, I don't see plastics degrading, once it's on the roadway from ultraviolet or solar radiation because of the small dosage. But again, we need to make sure that from a pavement performance standpoint, there's no net negative effect. I don't see leachate being a concern for plastics. Molecularly, it's a tougher chain compared to bitumen, so it won't leach as much once it's bound within the hot mix asphalt pavement itself.
Yeah, it'll be interesting to see the data as people start to look at those types of studies, and depending on how the highway reauthorization bill goes, it may be even more critical and more in front for everybody. So one of the things that you mentioned was really that long-term performance. In the US, we haven't been putting plastic modified roads down consistently for the last 20 years, so we've got long-term performance data. Really, some of the first ones started within the last year and a half. How do we help understand what the long-term impacts of this might be for the industry? Because we don't want to do anything that's going to have a negative effect on our long-term performance and how our roadway owners and the general public even feel about driving on asphalt.
So long-term impacts are important. What I can say is the work that Colas, and previous to that, it was Scragg, which Colas acquired. Scragg had done a lot of work with recycled plastics in hot mixes, specifically high modulus mixes on their major toll roads, major highways there. And actually, Jean-Paul Fort, he actually works for us at Colas Solutions Technical Center in Cincinnati. He was heavily involved in a lot of those early 1990 projects. Just over 900,000 tons of hot mix was produced by Scrag in France. So the performance is there, it's proven. Today, recycled plastics by the Colas company is used less, where we take the opportunity, because we do it from a plant process or dry process standpoint, is we target towards heavy duty type pavements, right? So there's typically smaller projects, toll gate areas or bus lanes, for instance, or bus stop areas. And that's because recycled polyethylene is more expensive. But the long-term impacts, performance-wise, it works for sure.
One of the next questions I think that's out there is really when we think about asphalt, 99% of our pavements are put back into a new pavement at the end of their life. So be interested kind of in your perspective of what impacts plastic might play if that's incorporated into our pavements in terms of re-recycling those pavements at the end of their lives.
Any type of modifier, whether it's recycled or new, the question as asphalt technologists we always ask about is recyclability of that mix. In France, the specifications are more performance driven, so it allows for companies like Colas to recycle any types of mixes or products that they mill off the roadway, but they're measuring it to mixture performance criteria. Whereas here in the United States, it's a little bit more complex, where we're looking at specific impacts on binder, for instance, to see how it affects that, as well as cracking temperature in the mixture. So definitely recyclability of the mixtures, we need to go down this road here in the United States to understand the impacts, whether the wet or the dry process is utilized there. Similar to this would be like PPA, where PPA was introduced. Hey, you know what? It was a good thing, but too much of a good thing turns it into a disaster. And that's what we as asphalt technologists learned, was that too much of PPA was a bad thing. And same with REODs, and even steel slag fine aggregates when suppliers didn't fully understand our needs.
So Paul, we spent the last few minutes really talking about some of the unknowns and the questions that we've either partially answered or need to be more fully answered. Let's spend these last couple minutes talking about something that you mentioned, and that was the successful use of recycled plastics that Colas has had in their high modulus or their EME mixtures. What are some of the things that allow that mix to perform? Is it plastic sourcing? Is it we test the mess out of this thing so that we understand it, so we have higher confidence that it's going to work well? What are some of those things that we could bring and start applying to the US to have higher confidence that these will be the mixtures that we need them to be?
Richard, really good points there. The learnings that we had in France, we would bring them here, and it's just a matter of making sure that all the key stakeholders understand why these needs are required. Starting right from the recycling facility, the source and the type of plastics needs to be managed appropriately, and the quality characteristics. So that would need in itself quality control plan requirements, with the involvement from the hot mix producers and the DOTs to specify, here's what we need the quality of the recycled plastic to be. Part of this is the France CE product certification requires a robust system in place. Here in US, it's different for sure, because today I'm not sure that our recycling systems in the US do a lot of proper sorting out. So Colas took the dry process route because it was practical and it addressed the logistics at the hot mix plant, where we didn't need additional hot bitumen silos to store the modified binder in place there. In the US here, with our PGAC grading and using critical temperature and mass curve, for instance, it may not be an issue, as long as the bitumen is stable. So as long as it meets a PG grade that the owner specifies, then it may not be an issue using wet process in that regard.
Yeah, you're absolutely right that not just questions for the asphalt industry. There's questions in terms for the plastic recycling industry, and what it would actually take for them to get to a position to make this viable. There was a study that was put out that basically showed if we wanted to get to the point where we recycled 50% of the global plastics, it would take somewhere between 15 to $20 billion per year of infrastructure upgrades and investments to make that happen. Now, if you look at the investments that are happening, the industry is doing that and more right now. But they're definitely parallel paths in terms of we've got to be answering these questions while the plastic recycling industry is increasing their infrastructure abilities to hopefully do this, like you said, in an economic way.
Well, I definitely appreciate you taking the time today, Paul, to share your experience and different thoughts and opportunities that are out there related to plastics and recycling those plastics into asphalt.
Richard and Brett, thank you very much for inviting me on the Pavement Black. I certainly enjoyed it.
Thanks, Paul. I appreciate it. A lot of good information. We just want to thank everyone again for being here with us today. My name is Richard Willis.
And I'm Brett Williams.
And we just want you to remember, as you're driving around America's highways, someone from our industry paved it black.
Pavement Black is produced by Monica Dutcher of the National Asphalt Pavement Association, with podcast theme music credits to Coleak. You can find Pavement Black on most of your favorite platforms, including SoundCloud and iTunes. If you would like to suggest someone for us to interview, please email Richard Willis at rwillis@asphaltpavement.org. That's RWILLIS@asphaltpavement.org. Until next time, keep paving it black.